And we're back. Welcome to another episode of Pitch Week, Pitch Month, Week 3. And Daniel and I both did our homework and ate our vegetables, so we get to play with some code today. Let's pray. God, what a wonderful experience of having a loving Father. Even though we have no idea what the future holds, we have no idea where we'll be, what we'll be working on tomorrow. We thank you that that's always been the reality, that we are only dependent on your grace and your care. At any moment, our lives could change radically, and we just happen to be in a position where we're certain that that's going to happen, with Daniel's baby coming, with us looking for jobs, still looking for clients and other opportunities to keep the company afloat. We have no idea what will happen, which of the many activities we're pursuing will bear fruit, and on what time frames. And none of that matters, because you are good and you love us. So help us to enjoy our time, help us to do constructive things that build us up, that create multiple avenues for you to bless us, and keep speaking to us. If anything that we should start doing or stop doing, make it clear to us so that we really get to a place where we are deeper aligned with you and better positioned to hear your voice going forward. We thank you that nothing is wasted in your economy. So we pray that we would not waste our time. In Jesus' name I pray. Amen. Cool. So I thought would be a good next step is, before diving deep into the guts of SWAN again, is to actually continue our conversation about web frameworks. Because we were talking about Angular and what you liked and didn't like. And I thought it would be fun to just think about what would an ideal web framework look like based on everything you know about Angular and Ruby on Rails and Node and things like that. What do you like and dislike? And just do some brainstorming around that. Just as I think it's a good exercise as we think about going into new companies which have their own way of doing things and their own technology stacks, to have a more informed opinion. And then after a little bit of insane blue sky, maybe go back to, is there any part of this we could actually build?
Mm.
So right now, thoughts, reactions?
Things I like. I like how in Ruby methods and variables are.
Give me a second to actually start taking some notes here.
Oh, sure.
Let's see. Design discussions and brainstorming. New page. Okay. Let's, okay. The things you like.
Syntactically, I like Ruby and how the methods and variables are declared and called the same way.
Mm-hmm.
It makes for a very easy interface in having dynamic values.
Is that kind of what we were calling dynamic properties in the hour of Node?
Yeah. I think so. Yeah.
Mm-hmm.
Let's see. Other random things I
Well,
like.
here's one thing. For me, Ruby on Rails is very much the one side, like the one ring to bind them all mentality. I mean, it's a little bit more modular in the post-MERB Rails 3 era, but that seems like a very different culture or technology opinion than the state of the art in Node, where it's a gazillion different modules, and most people have to pick 3 or 4 major pieces to do anything at all.
Right.
Your thoughts on this strength and weakness?
I think that I think modular code is great because modular code is like I think in principle, Node's ideas about having everything be plugged in everywhere,
Well,
um, it makes writing code harder because you can't just do exactly what you want to do. You have to sort of uh, work around it. It's like metaprogramming, right? It's harder, but usually the returns are awesome. It's harder to write, harder to test, but the returns are great.
so let
Um,
me. Okay, it's harder to create. So there's two different things. Is it harder to create or harder to use? And in practice, it's both, probably. But is that necessary?
um, I mean, I would say it's harder to create and easier to use,
So,
isn't it?
well, I know. My experience is that like getting started doing node development, it's really hard to find something like Ruby on Rails where you just say, just build this. It's more like, okay, I got to choose this piece and that piece and this piece. And is that a technical limitation, or is that really just a cultural phenomena because Ruby on Rails crushed everything? It basically was created first, and everything else came after. So therefore, it's monolithic.
Um, hmm, I'm not sure.
Let me put it this way: what would rather than think about what things are like, the ideal system would be completely modular in terms of being able to reuse, swap, and update at will, but feel monolithic in terms of presenting a simple, coherent interface to do everything.
Hmm.
Is that a fair statement?
Yeah, yeah. It does like I agree with you. It feels nice in Rails the way that everything it feels tightly coupled. It really does.
Right. And it's also like the difference between, well, so like the baseline would be the Unix shell, right?
Hmm.
Small pieces, small pieces loosely joined that at its best, everything just snaps together. Right? Is that anyone can drop in a new piece, and as long as it conforms to the right idioms, it just works. You feel like
Hmm.
they were all. You want it to feel like they were all designed by the same creator.
Hmm.
Um, and then the right and right now, nothing, very little in JavaScript feels like that. I mean, it's not as bad as Java, I suppose, where they were created by the same company, but it feels like you can tell which year different Java APIs were introduced by which idioms they use.
Hmm.
Um, but like there's three different module systems, and um, the like even just figure there's like even with an npm, I feel like I have to use like three different package managers to build something. Is that just
Yeah.
me, or is that actually endemic?
No, that's real life.
Okay, so so that's one thing. So let's see if we can start identifying a few themes. So themes. There's consistency, modularity. I think consistency is actually even maybe break things down a bit more, because the interesting thing is that like having a consistency, um, uh, you know, methods and variables, um, um, interfaces and idioms. um, sensibility, evolvability, it's in packaging. Um, the um, and there's, there historically has been a strong tension between modularity and consistency, right? Um, that the most consistent systems tended to be very monolithic, and the
Right.
most modular systems tended to be the most ad hoc. Uh, so
Right.
there's a question, right? Is it? Oh, right. Okay, that's the ideal system there. Okay. Um, other things. So here's another question about consistency. Um, there's this code, says HTML. Well, I guess there's server versus client code, and there's a code slash HTML slash CSS slash JavaScript consistency. And so in Ruby, it's a really big deal that you want your HTML to be or feel like Ruby code,
Mm-hmm.
right? And that's what with Reactive Coffee, that's one of the reasons. There's some efforts around CSS to do that. The whole JavaScript uh, world was, at least a big part of the motivation was to get consistency between the server and client code.
Mm-hmm.
Um, the Do you know anyone who actually does CSS as real code, or does it mostly tend to be these? I mean, I'm trying to like SAS, for example. Is that really Ruby code, or is that just another DSL?
I mean, it's not Ruby. It is DSL. Like it's very specific. Even the new syntax looks like CSS. There's lots of at symbols and dashes and things like that. Um, SAS is what can I say about SAS? Um, I mean, it doesn't really have like it's not dynamic in any by any means, right? Like it's you compile it and it becomes a static CSS file, right? There's the only sense of logic or that you get is um, breakpoints for responsive design. If the browser is this wide, then do this. Um, but there's not really I don't know.
Yeah. Okay. So there's the CSS programming is still kind of the ugly stepchild in a lot of ways.
Sure.
Um, and there was another word you threw out there, which I think is really, which is dynamism,
Hmm.
right? It's something that a system that is. I mean, that's one thing that I thought that was fun moving to Node is they've looked at everything that had been done in Ruby and Rails and made things way more dynamic, right? Because they have JavaScript, right? So you don't have to do the reload the page.
Right.
Everything just is watching and changing. Um, 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 I guess it would be what's the evolvability, modularity, consistency, dynamism. I guess that's the right verb. Um, which means like performant would be the next noun. Right. Narration where possible. Um, latency. Due to what are the other things that tend to make people excited about performance? I guess just speaking loosely, scalability.
Right.
Um,
And I mean, asynchronous, right, multi-threaded or asynchronous execution.
Yeah. Asynchronous execution. I guess next thing would be comprehensiveness. There you deal with the protocols, persistence, configuration. I'm going to throw scaffolding in there. But that's probably not the right bucket for it. Any other pain points?
Pain points. To me, one of the things that I have loved about Ruby on Rails that is very difficult for me, that has at certain points been difficult for me to grasp in other frameworks, is context. Like I felt like the Ruby on Rails documentation and the was always very clear about who has access to what. Right, sharing instance variables to. There's one way to get variables to the view, and it's by declaring instance variables. Like you put an at in front of it. The end. And that is it's always been very clear and very concise. Whereas even in my work with Ember, scoping issues like that seemed way more difficult.
Yeah, that's the interesting thing, is that by its nature, Node.js modules have very strict encapsulation.
Mm-hmm.
To the point where it's so severe that people, I think when they build their frameworks, deliberately break out of it so they can get access to the stuff they want, right?
Right. So that, yeah, I mean, that's one thing that I would love to see is just genuinely simple, who's got access to what variables.
Mm-hmm.
Yeah. I'm trying to think of any other pain points that I've come across.
So let's probably think about the systems we hate to use and why people use those. It's let's call it accessibility. Like PHP.
Right. Dreamweaver, etc.
Yeah. Dreamweaver. Portability.
I mean, widespread installation base is helpful too. It used to be hard to get, to find a Ruby server. 6 years ago, you couldn't just grab any random web host with a server and assume that it would have Ruby on it. Whereas pretty much now you can.
Oh yeah, that's one thing I love that Meteor does, is that you can say deploy and give it a name, it'll just throw up a public website for you. It just posts you on Meteor.com. Why not?
Right. That is cool.
Yeah.
That is cool. But I mean, we have Heroku for that. Heroku's really easy to set up, really, for free accounts.
Right, but I mean, it is easy to set up, but it's not but not having to set it up at all is so much better.
Yes, you're right.
Pushed a web app out onto Meteor, right? Because I say type this line. Whereas he would not have had the patience to set it up on Heroku.
Fair enough. Fair enough.
So yes, it is way better than it used to be. Other reasons, what do people use? Why do they use it? Why do they love it? I mean, sorry.
Community. I mean,
Mm,
that's one of the things that the guy I was talking to at SupplyBid. I asked him about his preferences about Angular, and he specifically mentioned that he feels like the community is really good.
right, and there's two things. There's the size and quality, right? Like there's a massive Java community in terms of size. But I know very few people who love the Java community.
Right. Okay.
Right. Whereas, for example, Ruby has got an amazing community. What is the we are nice because Mats is nice. The one min philosophy, and
hmm
some communities have that culture.
hmm
And obviously, building something from scratch can't do much about the size for the near future, but we could imagine, building a community that was. And there is something about the way you design the technology that shapes the culture. Are you familiar with the hammer stack?
Hammer stack. Nope.
So this is I think if I got the right reference for it. But this guy's been building this identity, maybe mixing two or three different means because the name's mixed up. Um, 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 Aaron Hammerlov was basically trying to figure out the next generation of internet things, and he went through a whole bunch of different stuff with OpenID and OAuth and all these sorts of things. And I don't remember if it's the right guy or not, but if I'm getting the names confused. But basically what he said is that one of the things they're doing is trying to figure out how do you actually build a maintainable code base. And what he was saying was the most important thing is getting new people, right? Is that if you want to really have a long-lived code base, you have to have a really low barrier to entry for new people to get involved in the project. Otherwise, you get this problem where there's some guru who runs everything because he's really good at it, and when he doesn't work or goes away, you die.
Right.
Really structuring everything as a series of small modules where there's a really gentle way for people to take ownership of things.
Well, I mean that reminds me of that you sent me a message way back months ago, I feel, about some article about some open source project and said, this is how I would love to.
Right.
to
that was the article I'm talking about.
Oh, okay, yes.
That what it was, but yes, and that's thinking through the whole. So I guess that's maybe the next. I wonder if that's actually a larger scale bullet point for that reason. So let's because the community, there's so many things about that, right? There's the how welcoming it is, whether it's the policies or contributors for becoming a contributor. There's obviously is its size and hopefulness. There's the granularity, decision making, of authority, and then there's the I think did I talk to you about ZeroMQ?
ZeroMQ?
Yeah.
Yeah.
Right, about their community design process.
Not about their community design process. I just saw their product.
I think I got this right. Yeah, the collective code construction contract. You ever heard of this?
I've briefly.
Briefly. But yeah, but the thing is that basically this to me is like the the future of democracy, in that they've really thought through how to build a system where where they use distributed version control as a way to resolve arguments, so that encourage people to try things quickly in leaf nodes and then pull them back into the center quickly.
Mm-hmm.
And that if it's a correct patch, you define correct really precisely, and then say everything's got to be merged.
Mm-hmm.
And then anyone who wants to can create a stable release. And then you have to basically think really hard about public contracts and how that stuff works. And it's a very geeky thing there, but there's a lot of really deep thought that's gone into this. That and basically they designed their community development process alongside the first version. That one was interesting.
Mm-hmm.
They really created that as a high level thing. And by having, and one of the things that they talked about, which isn't obvious from reading it, but it was that what this does is that you can never stop people from being jerks, but you can make it obvious quickly that that's not acceptable.
Say that one more time.
You can never stop people from being jerks, but you can make it obvious that that's not acceptable.
Mm.
And that you design your processes and your culture such that if anyone starts acting like a jerk, anyone has the right to say, hey, that's not right. And they feel the moral weight of the community behind them. Right. But like, or even just the very fact that when two people, like one of the biggest sources of conflict on a mailing list is when two smart people want to do different things. Mm-hmm. And so because of this, they say, do both, right? Figure out where in the stack you have to add the fork point. You throw it in there and they say, okay, both do your own way. And then, that's actually you need a, that's something where between dynamism and performance is something like code collapse, or I don't want the right word for this. The idea is that you want to have the benefits of indirection without the performance penalty. You've heard the joke that any functional problem can be solved by adding a layer of indirection, and every performance problem can be solved by removing a layer of indirection.
Yes.
I don't know a brief way to describe that. Way to collapse indirection. Let's just call it that. So, verb tense. So these be like adjectives rather than nouns that look less weird. Modular, consistent.
I mean, it seems kind of all the same to me. But
the extra suffix is bothering me. Let's see if it looks the same either way. Maybe this is my copywriting genes. So the So I think those are probably a reasonable list of virtues that people argue about and talk about when building and comparing web frameworks, right? That's for 15 minutes, not a bad. Now the interesting question is, these are the themes. Of that list, which things do you think are like the biggest bang for the buck potential for improvement? Like, what is the thing that if we did this one thing awesomely well, then that would solve a really huge problem that no one else has solved? I think it's fair to say that a lot of these things are. There's nobody who is awesome at all these things.
Right.
So here's a hypothesis. System with sufficient uniformity that it is possible to rapidly compose and evolve.
I mean, to me, I feel like um, I I mean, I think batteries included. I mean, we've already talked about this, but I think batteries included is a hugely important part of it.
Mm-hmm.
But that's not a killer feature, right? Because you can make batteries included for nothing, and at
Right,
least it'll work.
right,
Nothing.
right. It'll work for that version.
Right.
But this is what I'm noticing in Node is that the batteries included versions are all incredibly fragile.
Mm.
Right? It says we're going to use these 5 frameworks, which are all on
Mhm.
their own time frames, and that's why none of them seem to have any significant traction.
Mhm.
Right? Is the monolithic ones, at least you know what they are, like Meteor.
Yeah.
But all these other Mensas and Mean and all this stuff, they have their little camps, but none of them feels like a Ruby on Rails.
Yeah. Uh,
But in terms of the hypothesis, is that so the so okay so this is the thing. Okay, the key tension is between modularity and coherency. Is that you can build things that are really coherent is between you know which are extremely coherent, but then that you have to evolve them in lockstep, or they're incredibly modular, and you have to hand wave and make them feel coherent.
yeah.
Mm-hmm.
I I kind of agree that. I mean, I, yeah, I'm pretty happy with that being at the top of the list.
Yeah. Really clever way we would.
And I mean, sorry, while you're typing, I know Rails has attempted to go in this direction. Like you can use active record
Mm-hmm.
outside of Rails.
Right.
Um,
Active record is, and you can use other things instead of active record, but that's
right,
fine. But it's very coarse grained modularity.
right.
Get okay. This is, okay. would get um, that's what clear. That's the second claim.
Yeah.
You buy that?
Yeah.
Because it feels like the hard part of like the community culture, the accessibility, building all these things, the those are really about, can I really bring in a module quickly that does what I want and make it feel like it's part of the system?
Mm-hmm.
Right. This creates right. This requires okay. This enables low barriers to entry, yet inspired. Which means that it's really easy to add a module that plays nicely, and it's really really hard. There's a lot of disincentive to create things that violate the social contract.
Mm-hmm. Mm-hmm.
This is one of the presentations I'm most proud of. I think I told you that I wrote in 1999 about the future, about the eras of computation, and how the next era is going to be around sync. I
Mm-hmm.
talked about the different kinds of systems. So that's what I want, right? That to me is innovation. Um, uh, you want to have lots of innovation with very little defects or defection. I'll leave that
Mm-hmm.
ambiguous. All right. So the not really hypothesis. Let's look at the proposal. Yeah, so that the hard part is defining a universal interface and ubiquitous categorization. Okay, or this requires. Let's do that. Is that you basically need, right? If you can define the right, if you could define the best possible, a truly universal interface that everyone conforms to, that describes what the module is on both sides, right? Both the external interface that it provides and the internal implementation, then it's trivial to cascade it all the way up and down. Is that jumping ahead too fast?
It is jumping ahead. I
Okay,
think I'm with you. I think I'm with you.
let me break it down a little bit better then. Let's say requires a scalable mechanism for modularization.
Okay.
In the counterexample is Ruby modules. They're great at that one level, but then nesting them becomes a real pain. And is that right? Is that like Ruby is a great example? You've got packages, you've got which scale to a certain extent. Then you've got modules, and then you have classes, and then you have methods, and it's a there's all different things. I mean, the worst one for me, every time I try to do a refactoring, is the distinction between file names and variable names.
Hmm. What do you mean by that?
Is that I want to rename a class. I have to rename both the variable inside the file, and then I have to go out to the command line and rename the file name.
Yes.
And I'm probably the only one who thinks that that's perverse, but it drives me crazy.
Why does it drive you crazy?
Because they're all just names. And they're the name for the same thing. Why does it have two different, completely unrelated representations with two vastly different mechanisms for changing them?
I mean, because I
That's
mean, would you?
always done it.
Are you saying that you want? Are you saying that you want the class to like? I hear what you're saying. I hear what you're saying.
Because the
And
internal name and the external name, either one should reflect the other, or you shouldn't have two different, right? It violates single responsibility principle.
okay,
Who owns the name of the class? Is it an extrinsic name or is it an intrinsic name? Pick one, and the other one becomes a shadow of that.
okay. No, I hear you. I get what you're saying. So, I mean, unfortunately, because of the world that we live in, it'd probably have to be the file name.
Well, we can always choose which world we want to live in.
Well, I mean, how do you choose a different world to? I mean, how do you choose a world to live in where you can live without file names?
You could put everything in a database, right?
Yeah, but then how's it editable?
Hmm? It's
How
that
do you?
um, if it's web, it's a web editor trivially, right? Actually, in the web, there actually is that there. It's much easier to gloss over that distinction, right?
That's yeah,
Right?
yeah.
Everything's on the web. Everything's got a URL. You can have a local cache, but that's explicitly, a read-only cache for certain properties, right? And that's another point. Uh, Requires uniform naming and strict access controls.
Okay, all right.
Right? If you have that, then you can pull off a lot of these other things.
Mm-hmm. Okay, cool.
Mm-hmm. So this is always the fun way to do it. It's like, if we could build something like this, or if we had a technology like this, we would have a shot at building something like the above,
Mm-hmm.
right? Um, okay, and then this is the next. This is where it starts getting fun. Let's need a partition of names. Smart. I don't know if there's a better way to phrase that. But it is, you want to be able to name things. Let's go to the idea of collapsing, right? Is that you know the difference between static and dynamic binding?
Don't think so.
Okay. Probably a better phrase for it is compile time and runtime binding.
Oh, okay.
If you know what compile time, so compile time means that I decide at compile time this is what it is. Runtime means I have no idea. I'll do it later.
Mm-hmm.
Um,
Right.
um, so is that the optimal one is actually link time binding. When you load the app, you figure out what can be known and bind that.
Okay.
Right? So if you know, right, if you know that these names will not change for the life of the application, right? This inheritance hierarchy will not change for the life of the application, then you can resolve the name now,
Mm-hmm.
right? And if you don't, then you keep it dynamic, and that should be done at link time. You shouldn't say, oh, when I compiled this particular unit, I'm going to freeze this forever, because that's stupid. It's unnecessary. That just requires all you need is really good access controls on knowing who gets to change what when, right? You can't do that in Objective-C or Ruby because anyone can change the inheritance hierarchy at any point in time. But if you had good access controls, then you don't need to worry about that. And that means you can have a fully dynamic, loosely coupled system from the programmer's point of view and from the developer point of view. And then you say, okay, I'm loading it in an app. I've given you all the metadata you need to know what I am allowed to change and what is undetermined at runtime. Go optimize it.
Hmm.
And it's done.
Interesting.
And so I got from a man named Dean Reese, and he wrote the original driver kit, and before that he wrote something called, driver kit I think was the next step version in Objective-C. And he told me once, I wrote a driver in Objective-C, I will never do it again. And when I started doing this research, I asked him why. He goes, because Objective-C does everything at runtime. And you can't afford those extra lookups in a driver. Every millisecond, every lookup, every context switch counts.
Hmm.
So when it came time to redo IOKit, I remember having that conversation with him back in, 1997. Yeah. He said, I'm not going to do it again, and we're going to do it with embedded C++. He says, which is, efficient enough, but it's a royal pain because everything is compile time. Right?
Mm-hmm.
Plus, if you disallow virtual functions for efficiency reasons, everything is compile time. And he goes, what's with that? He goes, well, because then now everything is fixed. What you really want is link time, right? Because that's when you know what the whole program is. But our existing languages throw away all the information you need to do that, as you play all these games for link time optimization and inline functions and all this sort of stuff. So I guess that's the next one. You need rich. Must preserve. About well, I guess in the dynamic language it's less clear, but I'm not sure if that's a obvious thing or not. I mean, in the world of dynamic languages, it's obvious. If you come from a C perspective, it's not.
Hmm.
Um, so having walked through this exercise and like these things here, okay, if I did all of that, if I did all the steps 1 through 7, do you feel like confident that we could pull off the stuff above, or is there, but wait, what about?
Let me think for a second.
And you can look at the file on your screen if you want to.
So, it is interesting. It does sound good. I guess my biggest question is how do you like where do you build this, right? I know that you're we are imagining writing right client side web apps with this, right? Modern web applications. But you have two options here. Like either one, super duper, like right, the current implementation of SWAN that we're writing is going to be extremely slow
Mm-hmm.
because we take JavaScript strings and turn them into JavaScript so we can use them for something else, right? Sure, I mean, unless it gets really complex, you may never notice that it's slow, but it is slow.
Mm-hmm.
Um, So if you really want to stick in JavaScript, your only chance for legitimate performance is something akin to CoffeeScript, where it's a transpiler, right? Take your Swan and turn it into JavaScript before a browser or node ever sees it. Uh, but it just seems to me like the dream is bigger than that. So I guess that's really my only question or hang up is what,
How do I get from here to there?
huh?
How do we get from here to there?
Yeah, I mean, are we thinking too small with web? Like, should we go lower level?
Okay. The the so first thing is right now we've got nothing. Right. So getting anything out there that we can look at and see is a huge step forward. That's the first answer. The second answer is asm.js.
Hmm.
Right? Is that the next step would be that rather than write JavaScript, uh, you familiar with that?
I think I'm losing you.
Do you know what asm.js is?
Yeah, yeah.
So code that runs in the browser have kind of settled on asm.js as a minimal runtime that provides a very small set of abstractions that browsers are increasingly being designed to optimize around. So rather than carrying all the overhead of JavaScript, you basically have something much more like a virtual machine that you're running on top of.
Mm.
And so that's sort of I think that's currently standard for Java for high performance code written in JavaScript is
Mm-hmm.
stuff like writing C code that compiles down to ASM.js with typed
Okay.
array. So that would be the next step. Um, the um, and that's probably as good as any. Um, I mean, and running on ASM.js is probably running on the server.
Hold on. Sorry, I'm missing every few words that you say. Um, I heard you say running on ASM.js is something, something, something running on the server.
So I guess writing a JavaScript thing running on ASM.js is comparable to running Ruby on the server,
Okay.
right? Is that the other thing is that um, once we have this language, um, okay, that's actually worth probably bringing this up a point is that uh, right, okay, that's actually a good point. Uh, uh, Maximal performance need easy way to port multiple backends, sim.js, real ASM, etc. Right, so right now our backend is CoffeeScript.
Mm-hmm.
Further down the road, you'd want to actually do real assembly,
Okay.
right? Or equivalent. That's actually the, the pitch I'm doing for the chip company is starting from the other direction. Is if you can give me low-level silicon, I could build this on this framework as an abstraction mechanism on top of assembly.
Mm-hmm.
Actually, actually before assembly, an alternative abstraction mechanism. That one we get kind of for free, but that's uh, a somewhat bizarre coincidence or providential discovery rather than a explicit design criteria.
Mm-hmm.
So yeah, the idea is that, and the idea is that that's why if we can build the thing once and it's tolerable performance, then I can build the thing in itself and have a nice clean self-hosting compiler that I can then iteratively bootstrap.
Mm-hmm.
And and the idea is that if I can make the code really small, and it happens to have a nice natural mapping onto low-level computational constructs like assembly or ASM.js, then performance, the next 10x of performance is relatively straightforward.
Mm-hmm.
The hard part is getting and again the underlying premise. So this was a fun exercise in that I think I got you to the point where I wanted you to go, starting with questions you cared about.
Mm-hmm.
And so did any step along that way feel forced?
You mean the conversation we just had?
Yeah,
No.
cool. And so we actually got all the way from a accessible, friendly web framework to, darn it, we need a really nice low-level mapping onto assembly language or underlying
Yeah.
circuitry. And this is all in, as I've talked about, maybe probably like solving the legal system is out of scope, or it's in scope, but it's like 20 years off,
Mm-hmm.
or at least 12 years off. This is in scope for this year.
Okay.
And in fact, you know,
Sorry, I missed what you just said. I don't know why, but I'm losing.
maybe because I switched over to without changing presenter mode. I don't know if that did it. All this stuff that we talked about on this wiki page is in scope for this year. And in fact, most of it is in scope for this month.
Okay.
Like, this is the thing I would like to build in the next few weeks before we start our full-time jobs. Is
Okay.
not necessarily the entire web framework, but the underlying primitives that would enable us to build that framework. SWAN.
Mm-hmm.
And in fact, actually, let's switch back. This is actually the what's the word for it? Proposal. Let's see. Themes. We should call this requirements. That seems like a fair way to describe that list.
Sure.
Yeah. Perfect, but then this is the proposal. The central concepts we must tackle head on are one, scope, two, encapsulation, three, abstraction. And that is the, actually, all these, which handles min resolution, worlds, which handles access control, abstraction, which handles layering. Right.
I'll be right back. I need to get some water. I've had the hiccups for a while, and I'm starting to feel bad.
Okay, please.
Okay, I'm back.
Let me let you know that while I go get some water.
Okay.
I have a bottle of water, and I have no idea where it is. Hopefully, it's not spilled out on the floor somewhere. So this is um, so let's actually be more. So naming, access control, composition. Um, does that seem plausible?
I think so.
Oops, it doesn't format properly. What's that? Oh, that's just too weird. Zen mode. Didn't see that coming. Um,
I think you just need a line break between
yeah.
your.
Thoughts?
I guess it feels it, it feels too big for me.
Too big in the sense
Yes,
of too many pieces?
in the sense of like it's like if we're working on a hypothesis,
Hmm.
we need to prove one point at a time to keep going towards the final piece. And I guess it feels like when I read this, the first thing I want to do is, all right, well, let's start building a JavaScript framework, right? But part of the hypothesis is that actually using SWAN is an even better way to do it.
Hmm.
Uh, I'm not saying I disagree with anything. What I'm saying is I feel like we really need to get SWAN. I feel like we really need to get SWAN doing something before we can talk about. I mean, I feel like it's useful to have some kind of future in mind in terms of its usefulness in web development, but I feel like Swan kind of needs to stand on its own almost before it can really have a chance to prove itself in this arena, right? Does it do anything well? Does it do its own things well? And then taking it a step further, can it build the world's greatest web framework?
All right, yeah. The sure, this is all uh, point. This is all unsubstantiated.
And what I intend to say by that,
Hmm?
again, it's not that I disagree, but maybe just that my brain is too small to actually think of the full stack all the way from Swan to this.
Right.
I think this sounds great, and I think Swan, honestly, this makes more sense to me than Swan. But but in a certain sense, I also feel like um, I also feel like you're kind of right that if we really want to take another step forward, in um, web frameworks, maybe we do need a new language. Maybe we do need something new.
Right. And the yeah, and the point is, and I think it's kind of subtly made, but I think it's actually critical, is that right now it is impossible to think this way in any existing language. You familiar with the Saber-Whorf hypothesis?
One more time.
Are you familiar with the Saber-Whorf hypothesis?
Saber-Whorf, no.
This old thing in linguistics. I think the strong form of it is that you can't think without language,
Hmm.
and therefore the language you use shapes what you can think.
Yes.
So that's the strong form of it. The weak form of it is uh, the language you use shapes what you do think. Like in English, you worry about the gender of people,
Mm-hmm.
whereas in French you worry about the gender of everything.
Yes.
Um, the tense is explicit in English; it's implicit in Chinese.
Mm-hmm.
Right? There's different languages that force you to be more or less ambiguous about certain things. You have to think about certain things because of
Mm-hmm.
the language. And most people subscribe to the weak form. There are a few holdouts who hold for the strong form that, like, if your language doesn't have a sense of numbers beyond 3, you can't meaningfully think about them.
Mm-hmm.
Like, there's a language that doesn't have like future subjunctive, and so they can't plan or something like that. I don't know if that's true. I subscribe to what I call the Lieutenant Worf hypothesis: is you can't defeat what you can't properly characterize.
Hmm. Okay, so what did you say it was? What's it called?
The Saber Whorf,
Saber?
SABER-WHORF, probably worth. And I'm no longer able to access the internet. Okay, there we go. Saber Whorf. Am I getting it wrong? Sapir. There we go. Sapir Whorf.
Sapir Whorf.
Also known as linguistic relativity.
Got it.
Um, yes, so the Sapir-Whorf hypothesis. Language determines thought, and I say that linguistic categories influence thought.
Mm-hmm.
Um, and you remember Lieutenant Worf from the Star Trek: The Next Generation? After
Mm-mm. I didn't really watch Star Trek.
Okay. The I guess I'm showing my age anyway. But in Star Trek: The Next Generation, they had a Klingon. You know what Klingons are, right?
Yeah.
Okay. They had a Klingon as a security officer. This big, bad, tough-looking guy.
Mm-hmm.
But there was this little problem that they didn't really have a stable of writers. They would get famous science fiction authors to submit scripts.
Mm-hmm.
And a really useful technique to show how big and bad and dangerous the aliens were was to have Lieutenant Worf attack them and get beat up by them. Right? So as a device, the first time it worked great. It's like, wow, this is big bad security officer, and this tiny little alien just threw him across the room.
Mm-hmm.
The problem is everyone started using that technique. And so it became almost like one of these cultural memes, as often happens with the Star Trek show, which gets abused to the point where it becomes a parody of itself, where pretty much anyone who shows up would beat up Worf. And therefore, the whole point of him being this big, bad, tough guy that demonstrated strength this way.
Disappeared entirely.
Right. So instead of arguing about Sapir-Whorf, I go with the Lieutenant Worf hypothesis, is that, because the bad guy would show up, Worf would charge the bad guy, and then get beat up by it.
Mm-hmm.
You cannot defeat a problem you don't properly characterize. And the point of view of language or non-language conceptual frameworks or pseudo-linguistic conceptual frameworks like this, and maybe even what Victor talks about, is they have to figure out how to properly characterize the problem. And the idea is that existing languages don't, it is literally impossible with the semantic tools that exist in those languages to characterize these problems. Now, you can use those tools to build something that lets you characterize those problems, but that's different, right? And so you can't do, this is why I keep talking about kenosis, about emptying CoffeeScript of all the stuff that's not SWAN and then building our own things on top of it. Is that, you know, the way I think of scope is fundamentally different than the way CoffeeScript thinks of scope. And the reason I need a language is because to properly manage effect, you actually need to consciously choose your sharing mechanisms at each call boundary. To say that when I pass you something, am I passing it as a reference? Am I passing it as a value? Does it mutate the original value? There's all these tricky questions, which I've got partial answers for and some theory I can draw upon, but still a bit unclear. But the point is that it becomes a readability issue if you try to, well, first of all, is that actually every language, its call boundaries are in some sense the most fundamental aspect of it. Its API, right? If you can make something that looks like and acts like another language's call barrier, you almost don't care what the language is. Like if you say JavaM, right, that's our ABI. And the point is that our ABIs are fundamentally broken. In particular, the first evolutionary step from assembly language to C was coming up with a rigorous ABI. Right? Huge advantage. Solved a whole host of problems in portability and extensibility and modularity and so forth. And it was brilliant, except it was wrong. Right? The C ABI does not have any concept of effect. You can't say, pass this variable and never change it. Pretty much almost all the security problems we have with C stem from that. And so if you're going to solve that problem, you have to solve it at a deeper level than that, or emulate something higher on top of it. And the problem is that in some sense it's really hard to even think about this stuff without. I mean, this is kind of what you were noticing. Like, I was like, let's build this runtime, and why in the world would you want to build this runtime? You know, it just doesn't make. And so this is actually a surprisingly successful exercise to kind of walk you all the way back up and down the tree and say, this is what we're trying to do. And to get from here to there, there's lots of leaps of faith and miracles, but hopefully at least you have some idea where we're going.
Yeah, okay.
Whew. Okay. Let's break here. You want some time for your brain to settle, or you want to just take a 10-minute break and take a look at the code?
I'm fine with a 10-minute break. Let's get back into the code.
Okay, so we'll take a 10-minute break, and then we'll maybe run for a half hour, and then I got to split. So pick it up at 3:10.
Sounds good.
Thanks.
Thank you.